Innovations save roads destruction from global warming. Climate change and global warming are often used interchangeably but have distinct meanings. Similarly, the terms weather and climate are sometimes confused, though they refer to events with broadly different spatial and timescales. Weather refers to atmospheric conditions that occur locally over short periods, from minutes to hours or days. Familiar examples include rain, snow, clouds, winds, floods, or thunderstorms. On the other hand, climate refers to the long-term regional or global average of temperature, humidity, and rainfall patterns over seasons, years, or decades. Global warming is the long-term heating of Earth's climate system observed since the pre-industrial period, between 1850 and 1900, due to human activities, primarily fossil fuel burning, which increases heat-trapping greenhouse gas levels in Earth's atmosphere. The term is frequently used interchangeably with the term climate change, though the latter refers to both human and naturally produced warming and its effects on our planet. It is most commonly measured as the average increase in Earth's global surface temperature. Since the pre-industrial period, human activities have been estimated to have increased Earth's global average temperature by about 1 degree Celsius, 1.8 degrees Fahrenheit, a number that is currently rising by 0.2 degrees Celsius, 0.36 degrees Fahrenheit, per decade. It is unequivocal that human influence has warmed the atmosphere, ocean, and land. Transportation and its supporting infrastructure are among the biggest climate change challenges as the world moves away from fossil fuels. Still, one area often overlooked in conversations about electric vehicles or batteries, or mass transit options is the condition of roads themselves. Researchers are looking at existing pavements and how they perform under increased climate stresses, including punishing heavy rains, rising coastal sea levels, and hotter temperatures. The 2010 floods in Australia caused devastation and damage across Queensland, killing 33 people and costing the state billions of dollars. The floods also caused damage to 19,000 kilometers of roads, including those used by emergency and delivery vehicles. It was a dramatic reminder of the importance of weatherproofing Queensland's most vulnerable roads. Since then, Queensland has used a technique known as foamed bitumen stabilization. Small amounts of air and cold water are injected into hot bitumen, the sticky dark substance commonly used for road surfaces. After that, the bitumen expands and forms a water-resistant layer. As a result, the road surface or pavement becomes stronger while remaining flexible, making it more resistant to flooding. This was actually tried and tested on Queensland's roads during Tropical Cyclone Debbie in 2017, says Caroline Evans, chair of the World Road Association's Climate Change and Road Network Resilience Committee. When the waters receded, the pavements were still intact, so they didn't need to be fully rehabilitated afterward. These are special coatings and tiny hollow ceramic particles that lighten the color of the streets while also reflecting solar radiation. Some of these heat-shielding pavements could reduce surface temperatures by up to 10 degrees Celsius, Ms. Evans says. This solution can also help reduce heat island effects, in which cities are much warmer than surrounding regions due to airflow being blocked by buildings and a lack of greenery. Foam bitumen stabilization has also been used on other roads as part of Queensland's efforts to make its streets more flood-resistant, and it has proven to be more cost-effective than traditional asphalt. Queensland faces significant challenges because it has the most extensive state-controlled road network of any Australian state or territory, with over 33,300 kilometres of road. In addition, its transportation department has built 1,000 kilometres of foamed bitumen road surfaces and is continuing to develop foamed bitumen techniques. This is one of many technologies being tested on streets worldwide by authorities. From landslide-blocked roads in Nepal to washed-out coastal highways in the United States, collapsed bridges in Kenya, and melting ice roads in Canada, an increasingly volatile global climate threatens to disrupt critical transportation infrastructure. It is, however, inspiring a massive amount of innovation. One of the most severe issues with roads is their susceptibility to high temperatures. Extreme heat can cause pavements to soften, resulting in more cracks, buckling, rutting, and surface depressions. According to Philo Makona, a research engineer at South Africa's Council for Scientific and Industrial Research, the precise effects are dependent on local conditions. There are so many variables that determine a road failure, and the road can actually fail in many different ways. Tokyo tested a solar blocking paint coating developed by Nippon Corporation, a Cool Pavement Society member. According to the report, solar heat blocking paint will have been applied to nearly 3 million square meters of the country's road surfaces by the end of 2020. While such coatings may protect the road surface, they may also make life more difficult for pedestrians. According to research conducted in the United States, reflective road coatings radiated substantial quantities of heat upwards. The price of doing nothing will be high. For example, according to University of Colorado research, if actions to combat rising temperatures and increased rainfall are not taken, the payment for constructing and maintaining roads across Africa could reach $183 billion by 2100. Ms. Evans believes that, while there is strong international interest in innovative road technologies, the level of funding investments in the technologies varies by country. Instead of immediately attempting to upgrade an entire road infrastructure, she suggests that one way to keep costs in check would be to look at targeted sections of vulnerable roads. This could include more preventative maintenance in specific areas, which would be less expensive than after-the-fact repair work. Costly materials and processes are not always justified. For example, roads with little traffic can be built with low-emission materials like soil and laid by human workers rather than heavily polluting machinery, according to Ms. Makona. Low-volume pavements also provide an opportunity to use recycled and waste materials for construction that might otherwise be destined for landfills. These are typically associated with lower emissions. Due to the limited availability of sand, alternative materials are essential. The use of waste and recycled material will likely present a cheaper locally available alternative material to modify bitumen to resist the distresses associated with higher temperatures, says George Nturi, a senior research scientist at South Africa's CSIR. Recycled tires were tested on a road section in Gauteng, South Africa, and the material showed no heat cracks. We are continuing with further construction and testing also to demonstrate the various ways of using waste and recycled materials in road construction, said Mr. Nturi, who was participated in the test. Other materials that could be used include recycled plastic and glass. It may not appear evident that such substances could withstand high temperatures and heavy traffic, but depending on the form the material comes in, it is something that can be used, suggests Philo Makona. Further research may be required to find alternative solutions to bitumen and plastic, which are both oil byproducts. Also, Ms. Makona adds that some low-lying fruits can be taken advantage of. These include routinely maintaining stormwater infrastructure and thus improving drainage, as well as planting trees alongside roads to shade pavement structures. While many promising innovations for improving road resilience are still in the testing and design stages, Ms. Makona remarks that many other technologies exist and have been tested. What is needed now is a push from industry and governments to make them more widely available. Notwithstanding, humans are responsible for their destiny. Road construction accelerates climate change. Roads are a tool of human dispersal that has allowed us to utilize land that otherwise would have been difficult to access. At the same time, however, they pose a substantial threat to wildlife by limiting its dispersal and the risk of road kills. Roads also severely impact adjoining forests by causing a physical fragmentation of the landscape and a thermal one. A road affects the microclimatic conditions in its surroundings, leading to an increase in temperature. This can have devastating effects on the trees and land. The microclimatic change can increase water evaporation, heat stress, tree mortality, and forest fire risk. This impacts groundwater resources and the resilience of trees to climate change. A study in Oberhessen in Germany now confirmed these impacts, analyzing the environmental impact of a planned highway construction. They concluded that the highway would substantially reduce the cooling effect of the forest through tree mortality. The whole world, especially Europe, is losing green spaces to constructing roads and other surface sealing activities at accelerating speed. Unfortunately, we miss out on many ecosystem services that natural areas provide. These include water retention, cooling effects, air purification, and CO2 storage.